you have spent enough time in Neos, you have probably heard the term ref hacking, prescribed, often jokingly, as a solution to problems that appear difficult or have no immediate apparent solution. Yet, if you actually try to learn about ref hacking, especially if you are in the English-speaking community of Neos, you will likely be met with hostility and an outright refusal to teach it to you. As such, I realize that by making this tutorial, I myself will likely be ostracized by others because of it, as many are of the opinion that the method of ref hacking should not be common knowledge amongst Neos players. However, I am making this video anyways, in direct opposition of the effort to try and censor this technique among English-speaking players. I specifically mentioned the English-speaking community of Neos being the main opposition, as the Japanese community actually has a completely different perspective on this. Among the Japanese community, players and mentors alike are extremely open to discussing the topic, and I've even made guides on how to do ref hacking, though they don't refer to the technique as such. In fact, the guide that I'm going to use is from the Japanese community, along with some other helpful tips that I have learned from Japanese players. To the Japanese community, thank you for teaching me. I make this guide for the English-speaking community, as there is currently not much documentation on it. Before talking about ref hacking, I would like to give a warning. As mentioned, ref hacking is typically seen as a taboo subject among English-speaking players within Neos. I myself have already been ostracized from many players for even mentioning the subject. As such, I would not recommend discussing it openly, as you will likely be met with hostility. As a second warning, this video is for educational purposes only, so that whenever someone mentions ref hacking, you can know what they are actually referring to. If you are planning on using ref hacking, however, I would suggest 3 things. 1. Don't use ref hacking. It is likely to break in the future and can produce undesired results if not done properly. 2. It is a last resort. If you are going to use it, make sure that you've exhausted every other possibility first. 3. Beware of others. If you want to practice or learn more about it, do so privately. You will most likely be met with hostility otherwise. With all the warnings out of the way, let's get into it. In order to understand ref hacking, there are a couple of prerequisite topics that I would like to broach. The first one being references themselves. Everything in Neos has a reference, or address. The reference to an object in Neos refers to the address that the game looks for that object. You can see the reference of an object in Neos by grabbing it from an inspector. These addresses are stored as hexadecimal numbers, and are unique for every object. I like the analogy of an address, as it gives a sense of space, and more importantly, neighbors. If you look at a slots reference, then one of the slots components references, notice how the 2 numbers will likely start with the same numbers. In a sense, they are close. This is a result of how objects are stored in Neos. As an example, let's have a look at 2 different slots with the same components. The first slot, slot 1, has the following reference. The component of the first slot has this reference. If we take the difference of these 2 references, we see that the component is essentially that far away from that slot. We can think of this difference as the distance between that slot and that slot's component. Similarly, if we look at the second slot, slot 2, notice how the distance is the same from that slot and its components. This is a core principle important to understand for ref hacking. Specifically, if we have the reference of an object, and we know the distance from that object to a property we want to change, we can take that object's reference, add the difference to that object's reference, then write the value we want that property to have to the resulting reference. That is essentially what ref hacking is. First, I want to show a minimal example of ref hacking. Then, I'd like to describe a scenario in which it currently might actually be useful. Alright, so for this first example, I would like to do a simple ref hack for making the value of a value field of a Boolean true. I'll describe what I mean. So if I create a new empty object and I attach from data value fields type bool, what we're going to do is we're going to start at the address of value fields, and we're going to add the difference between the component and the value reference, and we're going to write a value of true so that it will essentially do that. And so the first thing I want to do is get the reference for this. And we can go, I think you can just get it straight up. If not, we'll have to write it. Okay, no worries. So what I'm going to do is we're going to write this to a variable. And in order to get this variable type, we're going to have to create a variable node for it. And there's a couple of nodes, a couple of ways to do this. The easiest way is to go to Renium's public folder, go to develop, and go to the ref type analyzer, and just put it in here. And we have the thing we need right here. Alternatively, you could create an empty object and store a reference field of type I world elements, puts the reference to this and that, and then we can get the type with logics at this point. We can go to references here, and we can do operators, get type. And we can see the type is this Fuchs engine blah blah boolean right here. And so in order to actually create the variable to store this, we're going to create an empty. Going to attach a component. Logics, variables, storage, a reference register. Put it there. And I'm going to take the empty and unpack. And there we go. And we no longer need this stuff. Again, different ways to do it. Thought I'd show you both. I would recommend just using Renium's ref type analyzer. It's by far the easiest. Alright, perfect. So I'm gonna pulse it so it's written, and I'm going to go to references, ref ID, there we have it. And we have BC, what, 4C900? 4C900, yep. So that's correct. That is the value we want. And just as a quick little check here, I'm curious. Could I have instead? No, okay, perfect. Alright. And I also couldn't have done this. No. Alright, so now that we have the reference, we're interested in just the pure number bit of it. So we want to get rid of the ID bit of it. And there's a couple of ways to do this, but there's two main ways that I've seen out in the wild, both of which involve converting this to a string first. So now you can see we have the reference as a string. And the first way that I've seen is to do a substring, which is right here. and we start at index 2. And as you can see, this gets rid of the ID bit at the front. The other way that I've seen is to do string remove, where we start at 0 and we remove 2 characters. You can see either way, we get the same result. I'm going to be using string remove for no particular reason. You could do either way. Either way works. So now that we have the reference as a number, we actually want to, convert it to a number so we can use it to do addition and stuff on it, because we want to take this address and then literally add the difference. And so I'm going to go to operators, parsing, and we're going to parse a ulong. And the type, you can just go left one, will be a hex number. And so this is the base 10 representation of this reference right here. And we literally just want to add the difference. So go to operators, add. And what is the difference? Well, you could do the same thing with the actual value field, get its ref ID and toString and all that. But there's a tool by ToteGamma that's really handy. I'll also link it in the description along with Rhenium's public folder. That is the offset checker. And so I'm just going to see what the offset is from this to this. This has an offset of 768. So I'm going to put that in here, 768. There we go. And so now this result right here, I'm going to put that back to a string. So string to string right here. So now we have our results. Now, how do we actually take this and write to it? Well, we're going to be using a component called the primitive member editor. And primitive member editors are typically used for UI things, like the color member editor, etc. But we're going to be using it in a bit of an unintentional way here. I'll demonstrate. So I'm gonna create a new empty over here. I'll just call it refhack for now. And I'm gonna make a child. I usually just give the primitive member editor slot its own slot, call it PME, and it's gonna be under uncategorized. And so we want to scroll down until we find primitive member editor. This is the tool that will allow us to arbitrarily write 2 reference addresses. So first we're going to tick continuous and then path. We're going to prefix it with ID. So it's going to be ID there. And it's expecting a couple of fields, targets, editor, drive, button, because again, it is typically used in a UIX sort of environment. But we can just give it dummy data. And I'll show you what I mean. I typically just put it in a slot called data or dummy data. And we're just literally going to add what it's expecting. So UIX, interaction, text fields. We don't need the rect transform or even the actual text field. We just want the text editor. Put it into there. The next thing we want is the text drive. So I'm going to go to UIX, graphics, text. We don't need the rect transform. I'm just going to put text inside of here. I'm going to put the content inside of text in the text drive. And then button, I'm going to attach UIX, interaction, button. And we can get rid of that text transform. Just put the button there. And the actual target, I'm going to put it at the top here. The target is where we're writing to. So I'm going to go data, reference fields, and for this type right here, I'm going to put in I fields. Just like that. And the reference there is what I'm going to be using. So there we go. So now what we're going to do is we're first going to write this string into the content of our text, because that is going to be the text drive. So I'm going to go to actions, write. So after this is done writing, I'm going to write to content. Right? Perfect. And after that, this is where we actually get to write true into that reference that we've been constructing at this point. So here I'm going to write, I'm going to set the type to Boolean, so input bool, and I'm going to references, I'm going to spin it, it goes this way, and we're going to go to our reference here, the I field, and we're going to write to our reference. So we don't need this anymore. And we're going to write true to that. Perfect. And so in theory, whenever I pulse, it will go get the reference address of value fields, and then it'll add the offset, which is 768 from here to here. It'll write the string to the text drive of the primitive member editor, and with its target prefixed with ID, because references start with ID, we will write a value of true to the reference that it's targeting. All right, TLDR, this should be true whenever I tick pulse. There we go. We could do the same thing. We can tick false, pulse it, and it'll be false. So there we go. This is a basic ref hack. And yeah, that's about it. Alright, this next example of ref hacking is one in which it might actually be a little useful. And I'm talking about baking meshes. So I already set up a little example here. I just have two quads, and I'm going to bake them together. And so I'm going to go to Assets, Bake Meshes, go Meshes here, and Destroy Original is going to be false for now. And I'm going to Collider Handling, I'm going to always add it. And so we can pulse it here, and we could see we have this mesh. Essentially kind of half a room. And we're going to use ref hacking to do two things. Set the type to static and enable character collider, so we can actually collide into the corner here. And the reason why ref hacking is currently a useful way to do it is because you could use a tooltip and point down and just kind of click it. But in scenarios in which you're procedurally generating the mesh, especially with within logics, with tries and whatnot, sometimes it could be hard to determine where you need to place the actual tooltip so that you can actually hit it, especially if you're procedurally generating other things that might intersect and get in the way. Not to spoil a project I'm working on, but TLDR, ref hacking is actually, for me, the best way to do this. And so how do we do it? Well, the first thing I want to do is this gives me the actual slot here, the meshes baked slot. So I'm going to write this slot to a variable. So I'm going to go actions, write. So when this is done, I'm going to write this to variables, storage, slot. And then I'm going to take the same thing. What I'm going to do, essentially, is we're going to start from the slot, and we're going to work our way down to first the type, and then the character collider. So I'm going to store those offsets over here. So beforehand, I'm going to take the offset from here to type here. It's 12544. So I'm just literally going to take inputs, uncommon, ulong, put that here. This will be the first thing we do. And the next thing I want to do is write true to character collider. So there we go. So now we have the two offsets that we need. And so I can delete this now, and we can just begin. So I'm going to go to references, ref ID. You know the drill by now. We're going to take this to a string. To string. And we're going to go to string. I was just there. Oops. We're going to remove the first two characters. And right now it's 0 because we haven't written anything, but this is what this is. 190 F2 600. It's the slot reference. So for now, I'm going to just get rid of that. And we're going to parse it as a hexadecimal number. So operators, parsing as a ulong, hex. I'm going to go to operators, add. And this is the first one for the collider type. And we're going to again go to string. So after this is done writing, we're going to write this string to, oh, we're going to need a primitive member editor. So I'm going to make a child object here. Call this, same thing as the minimal example, ref hack. Going to attach a data, reference fields, I fields. I'm actually going to have two of them because we're later on going to want to do the other thing. And I'm just going to keep that on its own thing so I can, And then here, we're going to put our primitive member editor. Attach, uncategorized. We're going to go to the P's. I'm going to P, primitive member editor. There it is. I'm going to make two of them. I'll call this one, PME type for the collider type, and PME bool, just so I kind of know which one's controlling what. And both of these, I'm just going to put some dummy data. So here's the data for the type. So UIX, interaction, text fields, don't actually need the text field, just need the editor. UIX, graphics, text, don't need the rect transform, just the text. And I'm going to put the text editor here. Text. Oops. Not the text, the content. We're going to put the content in the actual text drive. And we're going to put interaction button. Oops. Again, don't need the Rex transform, just the actual component. All right, continuous. It's again starts with ID, and we're going to be using this first ref field here for the target. There we go. So now I'm going to take this data, the text, and we're going to write to the content. Then after we write to the content, we are going to write the collider type. And so a lot of these specific types that we need to write to, you'll have to make yourself. And so collider type, you can get that by doing logics. Let's see, input, enum, and it's collider type. And we can just unpack this empty right here. So we're going to be writing static this way. After this writes, we'll be writing static to this reference right here. The first one, that's the target of our primitive member editor. That is getting the reference written to by this after we've manipulated it and added the offset. So I'm just going to get this first reference field right here. And we're going to go to references, little arrow, backwards. And there we go. And so we can test this out by simply pulsing this. So in theory, when we pulse this, we will get a mesh that will have a static type collider. So let's see, did I actually... Yeah, here it is. So on the baked one, it now says static. Good. So now all we gotta do is do the other one, character collider. And so same thing, I'm going to make some dummy data here. And I'm going to attach UIX, interaction, fields, which we don't actually need those. Attach UIX, graphics, text, boom. Attach UIX, interaction, button. We can get rid of that. And then we can get rid of that. We're done with that one. So now we're going to be using the ref hack for the boolean. And so continuous starts with ID. And we're going to just feed it in. Text editor is there. Oops, didn't get that in. Content from the text will be our text drive. And our button right here. Whew, there we go. And now all we have to do is take this, and this time add the difference, the offset to the character collider boolean. And again, toString. And we write this. I'll do it after this one. We write this string to the content of our dummy data for the bool, so our text. So we're going to write this to the contents because this acts as the primitive member editor's text drive. Oops, didn't want to do that. Then we're going to write true. Inputs.
Boolean true. I'm gonna write true to references. To our second reference here. Oh, and before I forget, the target, we need to actually specify the target. It's going to be the reference of this other I field here. There we go. All right. Speaking of, I need to actually get it. And just right there. Perfect. Okay, so what we've done is we've taken the reference to the resulting slots of the mesh that we're making, and then we took the differences of values that we want to change, and now we're writing to those references, the values that we want. In this case, static for the collider type, and true for character collider. So now when I pulse this, let me get rid of this. When I pulse this, I'll get this little box thing, but I should be able to collide with it. Pulse, and there we go. You can see here that we have type, static, and character collider true. And ref hacking is actually really useful for scenarios like this, in which you know the offsets will be constant and you want to change the property. But with the bake meshes node, there's not really a way to set these things. All we have is always add the collider.
That's all for the topic of ref hacking I have for you today. Just remember that this is mainly for educational purposes, and I would not currently recommend openly discussing this topic with others in Neos. If you have any questions, feel free to let me know below. See ya.